This is for Algebra 2, and this is for building rationals. We're kind of going at things from the opposite direction. Instead of me giving you an expression and asking you to find the vertical asymptote or the holes or the horizontal asymptote, I'm giving you the vertical asymptote or the holes or the horizontal asymptote, and you're going to actually create an expression. You're going to discover that every expression could be a little bit different as far as this goes. There's a few requirements that will have to be met. Beyond that, there's numbers and variables that you can choose. My suggestion is that you do holes, then vertical asymptotes, and then horizontal asymptotes. This first one does not have a hole, but it does have a vertical asymptote at x equals 0. This means that you have to have an x in the denominator. You have to have a horizontal asymptote at y equals 0. When you have y equals 0, this means that the denominator degree is larger. So if I have x to the first in the denominator, I have to have x to the 0 or smaller in the numerator. Well, x to the 0 means there's just not an x. So this is where everybody's problem could look a little different. Any number can be put in the top. You could put 1, you could put 5, you could put 8. So I've created a rational expression that has a vertical asymptote of 0 and a horizontal asymptote of 0. So looking at the next one, it's going to go a little bit more work for this one. You have two vertical asymptotes. Remember, a vertical asymptote goes in the denominator. You're going to use the opposite sign because like this is going to become x minus 2 because when you moved the 2 over it would become positive, so you always use the opposite sign. So x equal negative 4 means we're going to have an x plus 4 in the denominator. There's no holes, so we're ready for our horizontal asymptote. Go ahead and do FOIL or distribute on the bottom here, and you get x squared plus 4x minus 2x minus 8. Combine your like terms here in the middle, and so your bottom is going to be x squared plus 2x minus 8. Your numerator is going to depend on what your horizontal asymptote is. If it's y equals 0, that means that the denominator has to be larger as far as the degree goes than the numerator. Since I have x squared, it means I can have an x in the top, or I can just have a number. Either one works. So you could just put 3. There you have it. Okay, so this one has a vertical asymptote at x equal 4 and x equal negative 3. So on the bottom, you're going to have x minus 4 and x plus 3. Go ahead and multiply that, and you get x squared plus 3x minus 4x minus 12. Combine your middle terms, and you get x squared minus x minus 12 on the bottom. I have a horizontal asymptote of y equal 1. Anytime y is equal to a number, this means that your degrees must be the same. And then your leading coefficients, the number in front of your x squared or whatever, have to reduce to whatever this number is. So it has to reduce to 1. Okay, for the degree to be the same, I have an x squared in the bottom. It means I got to have an x squared in the top. For it to reduce to 1 over 1, if I have a 1 in the bottom, I need a 1 in the top. There you have it. Moving to the back. Okay, we're going to have holes as well. A hole, remember, it has to be in the top and the bottom, so it'll cancel out. So we're going to have an x minus 3 in the top and the bottom, and it would cancel and make a hole. I also have a vertical asymptote at x equals 6, and so that would be x minus 6. So you need to multiply the bottom, and this becomes x squared minus 6x minus 3x plus 18. So combine the two in the middle, and you get x squared minus 9x plus 18. Now I have an x minus 3 on top, but I also have a horizontal asymptote at y equal negative 2. Horizontal asymptote at a number means that my degree has to be the same. I have x squared in the bottom. Got to have x squared in the top. All I have is an x. So I would need to multiply that by an x to get my x squared. It also has to reduce to negative 2. Right now, I just have a 1. So I need a negative 2 as well. So I'm going to take this negative 2 and distribute it, and I'm going to get negative 2x squared plus 6x, and that's going to be my answer. Okay, this one has two holes, so I'm going to have an x plus 1 in the top and the bottom, and I'm going to have an x minus 3 in the top and the bottom. I also have a vertical asymptote at x equal 1, so that means I'm going to have an x minus 1 in the bottom. Holes go in both places, vertical asymptotes only go in the bottom. So I'm going to multiply this, and I'm going to get x squared minus 3x plus, that's plus 1x minus 3, which would combine and give you x squared minus 2x minus 3. That has to get multiplied by your x minus 1. So this becomes x to the third minus x squared minus 2x squared plus 2x minus 3x plus 3. So when you combine things on the bottom, you're going to have x to the third minus 3x squared minus x plus 3. Now, if you multiply these on the top, I would hope you would get the same thing. So that would be x squared minus 2x minus 3. You have a horizontal asymptote at 2. So your degree has to be the same. The degree in the bottom is 3. Right now, the degree in the top is 2. So we need to multiply it by an x to get it up to the third power. It also has to reduce to 2 over 1. We have a 1 in the bottom, so we need a 2 in the top. So you're going to distribute this 2x, and you're going to get 2x to the third minus 4x squared minus 6x. And that's going to be, sorry, didn't mean to cover it up. That's going to be your rational expression that your answer is. Right there. So your last one, you have a vertical asymptote of negative 4, which means you have an x plus 4 in the bottom. That's all you have, right? Don't forget to think about a horizontal asymptote. If they don't tell you that, then you have to realize that there is none. And the rule for there to be no horizontal asymptote is that the degree in the numerator has to be bigger. So if I have an x to the first in the denominator, I've got to have x squared or higher in the numerator. It could be x squared, it could be x to the 5th, it could be x to the 8th, it doesn't matter. It's got to be bigger than 1. So if you just put x squared up there, you've met your requirement. Make sure on anything you do, if it doesn't say anything about horizontal asymptote, that means there's not one, and the numerator has to be bigger. Okay, that's it for the notes, so you're ready for the assignment. Let me know if you have questions.